All right, here we go on composing and decomposing functions. Ooh, drop my pencil. All right, tells us that if f of 3 is equal to 7 and g of x is negative 2 times f of 5 minus x over 3 plus 7, then what is g of negative 4? Okay, well, let's try. This says g of negative 4 means replace all the x's we see with negative 4's. And if we do that, we're going to get negative 2 times f of 5 minus negative 4, which is 9 over 3 plus 7. 9 over 3 is 3, so this is negative 2 times f of 3 plus 7. But f of 3, they told us, was 7. So this is negative 2 times 7 plus 7, and 7 minus 14 is negative 7. Okay. Multiply. Okay, we'll do that with an area model because that's what I like to do. Minus 3x plus 7 and 2x and minus 3. We made my boxes big enough. So I have a 2x cubed there, a minus 6x squared there, a plus 14x there, a minus 3x squared there, a 9x there, and a minus 21 there. And if we add all of those parts together, we have a 2x cubed. Negative 6 minus 3 is negative 9. X squared, 9 plus 14 is plus 23x minus 21, and that's what we get when we multiply those together. All right, on to the new stuff. If f of x is 3 over 2x plus 1, and g of x is 3x minus x squared, and h of x is log base 4 of x minus 2, then we're going to write some equations. First one, g composed with f of t. That means the f of t is going to come first. If I strung together my arrows for f, and I'm going to start it with a t, then it says multiply by 2, and then add 1, and flip it over, and multiply by 3. So there's f, and then that will go into g. G is this one big polynomial area that says do 3 times whatever was at the beginning of the arrow and subtract whatever was at the beginning of the arrow squared. So this becomes a 2t. There's my 2t plus 1. Here's 1 over 2t plus 1. Here's 3 over 2t plus 1. And I'm going to end up with a 3 times 3 over 2t plus 1 minus 3 over 2t plus 1 squared. Okay. We could multiply some things out there, but for now that is sufficient. Okay. Our next one here is going to be 1, 2, or h of f of g of z. So the g function in this case is going to come first. And the g function looked like do 3 times whatever and subtract that squared, and we're going to load a z in. So this will give me a 3z minus z squared. That then is going to go into the function f. That was my other string of arrows there. Some things here and make a polynomial arrow of that one, since I'm not coming back the other direction. That says do 2 times the 3z minus z squared plus 1. And then flip that over and multiply by 3. After I've done that, I will have a 3 over 2 times 3z minus z squared plus 1. And then finally it is going to go into the function h, which just said start out by taking whatever the input is, subtracting 2 from it, and then putting that into the log base 4. So all of this whole thing, and I've got to keep track of the length of this fraction bar to make sure I remember that plus 1 is in the bottom there. So this becomes this whole thing minus 2 inside the logarithm. So we're going to end up with a log base 4 of 3 over 2 times 3z minus z squared plus 1 under that fraction bar minus 2 outside of the fraction bar, close it off. This is what our h of f of g of z looks like. Okay. All right, number 4, v of x is this polynomial function, and we want a v of x. So the v is one big arrow that says whatever comes in, square it, add 3 to it, and then add 1. And we're going to stack another one of those on here. So we'll start an x in here, run it through the v, take the answer, and run it through v again. Well, we know we're coming out here with an x squared plus 3x plus 1, and now this is going to drop into both sets of those parentheses and give us an x squared plus 3x plus 1 squared plus 3 times x squared plus 3x plus 1 plus 1. Okay. There is some simplifying that we could do. As we multiplied in problem number 2, we could multiply this. We could distribute the 3 through there and combine all of this into a simplified form. For the sake of length of video, I think I'll probably leave that for you. And evaluating v of negative 2 means I'm putting negative 2 in the beginning of this, or I could plug negative 2 in for all of these x's. I'm going to take this out for now and say if I put a negative 2 in here, I'm going to get a 4 minus 6 plus 1. Negative 2, 4 minus 6 is negative 2 plus 1 is negative 1. If I put a negative 1 in for all of those, negative 1 squared is 1, minus 3, plus 1, 2 minus 3 is negative 1. So this works out to be a negative 1. Okay. May come back and pause and do that simplification and write that in there, or just include that. I'll do that work somewhere else and I'll include that on the static solution. Okay. All right, decomposition here. If g of h of f of x is equal to this thing, then what are some possible functions for f and g and h? So to do this, we're going to write this with arrow diagrams to begin with. So we start with the x, and it says square, and then subtract 5, and then put that into a log base 2, and multiply that by 2, put that into the power of 10, multiply by 3, and change the sign. Okay, I have 3 functions that I want here. All I have to do is break this arrow diagram into 3 pieces, and I can do it any way that I want to. I'm going to go ahead and I'm going to make a break there, and I'll make a break there. Remember, in this order, the g of h of f of x, the first thing that's going to hit the x is the f. So these 3 arrows are the f. These 2 arrows will be the h, and these 2 arrows will be my g. So f of x, I just drop an x in the beginning. It says x squared minus 5 inside of a log base 2. So log base 2 of x squared minus 5. I could choose that for f. I could say h then, if I put an x in at the beginning of that, that's 2x in the power of 10, so that's 10 to the 2x. And finally, my g of x, if I put an x in there, this is 3x and change the sign, so that's just negative 3x. This is one example of a correct answer. I could break this absolutely anywhere in there that I want to, okay, and come up with different functions that would combine in there. Okay. Now 6 is going to be a little bit more specific. It says if you have that set of arrows and you know that the h of x is 10 to the 2x, so the way I chose it happened to work out exactly on this problem. I promise I didn't do that on purpose. But then it says, what is the f of 3? Well, if we define what the middle one is as the 10 to the 2x, it has to be these two arrows, which means the 3 arrows before that have to be the f. The 2 arrows after it have to be the g. And so since I've established that f is log base 2 of x squared minus 5, this is going to be the log base 2 of 9 minus 5, which is a log base 2 of 4, but 4 is 2 squared, so this is just 2. Okay. All right, and let's see here. If m of x is 3x minus 5 and n of x is 5 over x, then state the domains of m of x, n of x, m composed with n of x, and n composed with m of x. Okay. Well, for our function, let's see, the function here will have m in m circle n and n circle m, and the domain of m, since that's just a linear function, that is all real numbers, in x cannot be equal to 0. And let's take a look at what we get when we compose m and n together. So m circle n goes first. That is the x. Flip it and multiply by 5. And then multiply by 3 and subtract 5 when we put the m on after that. So this gives us a 5 over x. This is a 3 times 5 over x, so that's a 15 over x. And then we get a 15 over x minus 5. And that domain there is also x not equal to 0. Okay. When we do the n circle m of x, the m comes first. So the multiply by 3, subtract 5, that gives us the 3x minus 5, then goes into the flip it over and multiply by 5. So this is 1 over 3x minus 5, and this becomes 5 over 3x minus 5. And now the problem is wherever 3x minus 5 would happen to equal 0, which is when 3x is equal to 5, or x is equal to 5/3, so the domain here is that x cannot equal 5/3. Okay. So a couple of lessons here that the order that you compose in makes a difference. One way we got 15 over x minus 5, the other way we got 5 over 3x minus 5, and it changes what the domain might be as well. All right, in the static version, I will work out what this looks like in its simplified form, and I'll maybe come back in on this and show the breaks. In fact, let's just do another one right now. Okay, as an OR, here I could have broken this here, and let's break it all the way down here. Okay, so the f still is the first one, so my alternate solution here is that the f of x, if I break it there, is just going to be x squared minus 5. My h of x is all of these arrows together, so I've got a log base 2 of x times 2 put into the 10th power and multiplied by 3. So I believe that's going to be 3 times 10 to the 2 times the log base 2 of x for the h, and then the g of x in that alternate solution is just negative x. So there is another way that they could be broken up, and this answer is just as good as this answer. All right.